save as file. Itu saja untuk manning. And then semua dah tahu ke macam mana nak extract for era 5 data? Ada orang dah cuba ke tak? Yang ni. Kalau let's say you want to go for green, kalau you nak guna DFS2 file, we have to download 3 data. The first one is 10 meter U component V. Antara tiga ni perlukan untuk DFS2 for reinforcing, and another one is wind speed. Depend on which condition you want to run for. If you want to run for wind kat sini, if let's say kat sini ada dua pilihan. The first one is wind speed direction, and then the another one is wind velocity component. Kalau let's say you click for the constant in domain, boleh je tengok kat sini, try to click select, and then kat sini dia akan tunjuk keperluan file yang mana you perlu buat, sediakan. This one is DFS kosong, so it needs wind speed, wind direction. Dia akan tulis kat sini apa parameter yang dia perlukan. Okay. Kalau contoh you select for wind velocity components, and then wearing domain select. Sebab di sini saya tak ada DFS2. Dia akan keluar DFS2 kat sini. And then speed. Dia akan keluar dua, either you want to use DFSU ataupun DFS2. So kedua-dua file ni dia perlukan parameter X velocity, Y velocity and pressure. Pressure kat sini means sea level pressure, and X is mean 10 U velocity component, Y is mean for 10 V velocity component. So kalau nak convertkan net CDF, contoh yang dah download data kat sini. If you click for break ataupun next CF, nanti kat dash I generate tu, yang saya share link tadi, download tools tu, dia akan bawa you masuk untuk convert DFS, convert the grid file to DFS2 or DFSU ataupun from grid netcdf file to DFS2 file. Dia akan convert directly. So yang part untuk Vim tak payah guna MATLAB. Yang guna MATLAB hanya wave and kalau current diperlukan and current. These two. Okay. And then setakat ni ada apa soalan yang still confusing you guys ke? Before saya start untuk my HD in data preparation, ada apa soalan lagi ke? Okay, kalau ada, saya move for HD. Boleh pergi kat workshop file yang hari tu dah ambil, pergi ke data and then go to model simulation, tekan simulation ni. Sekejap, ini spectral wave. Okay, tak ada. Okay, tak apa. Buka mic yang baru. Then go for mic 21. Then from model M. FM means flexible mesh. Kalau kita guna triangular mesh, boleh go for this one. From model 1. Then if we are using flexible mesh, then we choose for the second one. Then just open. Then go for domain. Inputkan DFSU file. Go for model input. Then open. Then all this is default. Make sure your chord compare each other correctly. Chord 4 is go for chord 4, chord 3 go for chord 3, chord 2 go for chord 2. Sometimes ada orang yang akan name it as north, east, south, and then make sure it's correctly matched to each other. Kalau ni tak sama, maksudnya masa you adjust the line, the boundary tu dah salah, the numbering dah salah in order. Okay. Then go for time. For this one, we will run for okay. 116. Depend on data file yang you dah siap. Okay. Kalau let's say data you start from 1 August, then sini letak 1 August ya. Normally, if you want to run for validation, right, we will follow the times for AirVac or ADCP first. We will test for the validation, do the calibration and validation. And then it depends on the time interval in ADCP, this one. How to calculate the time step is, okay, this one. It's in second. If you, let's say, For airway is every 10 minutes interval, right? Then 10 times 60. So interval letak 600. Kalau airway time interval is every 10 minutes. 10 times 4. And then how to calculate for this timestamp is if let's say the airway is for airway ada 1 bulan punya data, tapi you have to add some more days as interval, soft interval to dia macam before you exercise you're gonna heat out your body first. So the same goes to this mic. Biasa kita orang akan letak 7 days as a soft start interval. Is let's say airway started date for airway is 11 November, 1st November. Then we will add 10, add 7 days earlier to like maybe 04. And this one saya setting as this because data I dah siap untuk ni. Yang biasa kita akan start earlier. Okay, for this time step is for example the kalau you ada 17 hari 17 hari plus lagi 7 hari as a soft start. Then it's depend on your domain. If let's say you use local domain, maybe you can use 3 day as a soft start interval ataupun 5 day. Normally I will use for 7 days because if not, the starting data will appear as 00, so it's not valid to do for validations. Then we will times for divide by the time interval yang dah set kat sini. This is for 1 hour. And kalau I 10 minutes, you have to change to 10 minutes to second. And then divide by 30. Okay. Then you will get this times that. How the decimal place? Times. Yeah. If 20 days, then we will put 80 at here. But in this situation, I use for 1.6 because I set up my data preparation. And then we'll go for, we'll take for mud transport and sand transport. Yang ni Min akan ajar nanti, tapi for this case, we just take first to extract out the data, format to extract out the data first. Then next class, Min will teach on MT and ST module. Okay, then we'll go for solution technique. If we choose for high order, the time taken for the model to run will be increased. And we should choose low order, it will fast but less accurate. And then it's depend on which one you want to choose. And for the maximum time, normally we'll use for this, the time step at here, the time step at the second one. And then this one is default 0.8. And then we'll go for that. That kalau tak ada that correction, just leave it. Kalau sometimes let's say saya run for South China Sea, because ada banyak pulau kat tengah, sometimes your model is will flooded ataupun kering sangat driving, so it cannot run. You gonna deepen your depth, and then in this time you can use this. It will specify the bed level change, and then we will change the DFSU. You can see a DFSU file. Macam yang tadi I buat, you can deepen your study area. If let's say the area the air tak boleh masuk sebab ada pulau. Okay, and then this one just default. Dry and dry default. Then density default. Certain study diorang ada include temperature and salinity to run for current, but indeed in our cases we don't include it. Kalau nak include boleh je include kat sini. So masa you guys download the data from Era 5, you can select for temperature too. Temperature. Yeah, sea surface temperature. In case you want to add it. Kalau salinity, I'm not sure where to get the data. Okay, you can check it later. Is that salinity in this era file or not? And then we will go for next eddy viscosity. And then this one, you can play around these two parameter, eddy viscosity and bed resistance during validation. Kalau normally ada range for this one, if you adjust this, need to adjust this too. It's depend. Tak silap saya Min hari tu ada share satu table, and then you guys can refer to that table. And then for same goes, kalau ada adjust manning, boleh guna Hello Min, ada ke online ke? Yang ni saya rasa tak silap kalau let's say you ada adjust for manning, you choose for varying in time and domain. No, just varying in domain. Varying in domain. And then select for yang tadi dah adjust manning. File yang ni. Yang dah adjust manning, you boleh letak kat part bed resistant. And then for this case, saya tak guna, so I put it as constant. So all the constant value will be calculated as 32 values. And then for this domain default, and then reinforcing if you want to include it. Now in this case, we go for sorry sebab saya tak boleh access UMT punya PC, so I only can use my laptop. But my laptop has some limits on mine, so better info. Yang ni saya extract as point form is TFS 0. Normally kalau nak do for validation, we will choose for the okay, sorry. Kalau let's say awake point kat sini, then masa kita extract out the wind data, I will probably use the most nearest point to the awake. Sebab yang ni kita akan buat for validation. So I will choose for, if let's say the awake is here, maybe I will choose for here. It's depend on the available coordinates data. Kalau ada point dekat kat sini, then I will probably choose this to extract out for reinforcing data. Data dia lebih kurang macam ni. Yeah. After you extract out, you will get the value for speed and direction. And also remember to convert the U velocity to speed and V velocity to directions. Okay. The formula for this is okay, direction speed. Okay. This is the formula on how to uh, convert from V velocity to the parameter. Then lepas dah convert kan, you all can like, dia akan ada kat Excel file. So from Excel file, for example, you want to make new file like this, the FS0, you can go for contoh, okay, contoh dia akan bagi contoh kalau dah extract keluar, dia akan ada data sini, 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 sini. Dan yang ni tak dimasukkan sebagai time series lagi. You have to create a time series files format to recognize the file. Then we'll go for my, then click the open file, new file. Then choose for time series. Okay. Then dia akan tanya nak time series yang macam mana, from ASCII file also can, from blank you create a new time series file also can. So we will select for a new time series. Then this one maybe you put it as green and red, and then you can select the time. Let's say the time is started from August 31, and masa yang kita extract out the starting time, and then the data is every hour or every 6 hours. You can mention here. For example, you download the data hourly at here. Okay, here. If you download for only 6 hours interval, then you only select for this part. And if you download for hourly, then you can select all. Just clear and select all. And if you download by month, remember if by month you have to be aware on this. For example, if let's say you choose for December, ada 31 hari, make sure you tick all. And when you come for November, and make sure you tick all. Because sometimes we miss one day's data. And then if let's say download hourly, okay, then here you marry as current speed. And one more. You can just type okay. Then automatically unit will come out, and make sure the unit is correct. And then for current direction, type current it will default count out radian and make sure you change to degree. If in another case you use for radian, then you can select for radians. Okay, then just click OK. Okay, then you just paste, go to the Excel, and contohnya this one is speed, you just copy, then you just paste at sini, paste kat sini direction. So dia akan siap, and then make sure you have to check the date is correct, then save. Just save as like green. So automatically we akan save as DFS0. Okay, save. So you can close it. Then okay, that's all. Then next, okay, that is entire green. Contoh kalau file yang dah buat tu masa tak ngam dengan yang setting kat sini, automatically you cannot input the file. So you have to adjust back the setting on your time data preparation. Yeah. Okay. Eyes coverage just default. Tidal potential no need to include. If in case you want to try an error, you can include. And then all this data can get it from file. You boleh ambil from Japan tidal books or Navy. Other constituent ni just insert the value. And then precipitation default, evaporation also default, and the wave radiation. Got two conditions you can use for. One condition is what we call it as wave current. Kalau you nak run for wave current, you must include the wave radiation. Wave radiation ni macam mana nak dapat data ni? Data ni boleh dapat from my SW. Dah run SW tu, you keep the output folder and then you just insert from this. Contoh, hmm, contoh, contoh SW yang dah run, ini file area dia, just click and then automatically dia akan detect the radiation stress XX, XY and YY kat folder SW yang dah run. Yang ni Min next week akan ajar. Dia just okay. Dia akan keluar kat sini. And make sure the date that you run in SW is valid and is matched with this date that you run in HD. And for those who only want the pure current, pure tidal current, and then you don't need to insert wave. Okay, it's depend on study area too. If Terengganu is mostly influenced by wave and current, and you should include the wave radiation during the model. And if in Selat Malacca Selat there, maybe you not need to include it because got wave got Selat Malacca is not so strong. Okay, then sources just keep it. And structure, if you have structure, you can add, for example, like turbine, wind turbine. You can just go to list view and then new turbine and then go for it and then just put the long legs for the turbine location and then how big the diameter is, either 5 or 10, and then all this just default. Okay, then that's all, and make sure the long leg is in which projection. For example, if this use UTM, then you should keep type in the UTM. If here you use long leg, then it will appear long leg. Okay. And then this one, okay, cancel. If you want to cancel, just click here, then just delete. Okay. And then go for initial condition. For this one, hari tu dah ajar untuk get this file, right? You can get either, for example, if I choose for this, you can see it need DFSU file and DFS2 file. Tapi hari tu kita extract only DFS1, so we will go for wearing C surface elevation select. Okay. Oh, okay, I'm not yet teach you guys how to. Okay, if let's say you use the FS1, there's only one way you can get this surface elevation is that go for uh, model input, boundary condition. So yang ni dah extract the FS1. So buka Excel. Okay, then contoh buka code dulu. We need to average all these parameter to get this value, surface elevation value. So we'll go for code 2. Buka code 2 punya file. Just copy, Control C, click here, Control C, and then paste it here. And then we'll calculate the average. Just select all this. Okay. And go for code 3. Control C, same goes. Ambil yang paling atas ya. Because it's as a initial condition, initial starting values. Oh, sorry. Initial starting value for your model. Paste. Compose. If let's say you only got 2 chords, then you just average for 2 chords. If you have 3 chords, then you have to average for 3 chords. So you need that part. And go for chords 4. E. This guy Then you have to average both three of these. So this is the final value you get for as an initial condition. Just Control C and then paste it in here. Okay. This is for if you use the FS1. Kalau if let's say you use for surface elevation, you can use the file DFSU. Yang ni kena guna yang full time mic. Dia ada tools ni untuk generate in DFSU format. Contoh yang boleh saya tunjuk, contoh initial condition. Contoh yang ni DFSU. Initial condition yang generates guna DFSU. Yang ni full time mic version baru boleh dapat value ni. So in our case, I don't think we can use for now. So we will go for this constant. And then this one is depend sebab kat Win, if let's say I'm using the DFS2, dia dah ada value untuk tu. Okay, so I just put it as default 0, then go to the boundary, go to the list view, and then make sure your chord map the chord that you have generated. Just press go to chords for change to specify level, and then in time along boundary. Then select for boundary condition. Go for yang ni chord 4, so pilih for chord 4. Then okay, why enter tak sama. Okay, and then it's the T should be in. And that only 12. Okay, so this one. Okay. Then default, and then we go for chord 3. Same goes, specify level, varying in time along boundary, select, then chord 3. If you're using river, right, you have to include the rating curve. If you use run for river soil. Okay. Then go to chord 2. Specify level, varying in time along boundary, select, and then chord 2. Okay. Okay. Land boundary, make sure it's 0 normal velocity. Sebab tak ada air kat bawah land. In case if you are using the large model to run, you can choose for flatter condition, and then this one kalau nak. But normal case is just this one. And if you need to use this, maybe you can contact me later. And because a lot of things have to do if you are using factor conditions. This will, if you choose for factor condition, it will make your model more stable because it will automatically help you to stabilize your model. If in this case, I think no need. Okay. Then decoupling, no need output. Create a new output. And then next as area. Area file is mean the FSU file for me. It's depend on you what you want to name for. Then please go to, sorry. Then go for output. And go for output specification area, then we choose area. Then how we want to create an output file is only one way. We have to click Control D, Control D. It will appear this and where you want to save your data. So I will go for result, then put error. Okay, then save. Just type in error then save. Yang ni yang dah run. Okay, then save. So dia akan automatic keluar here. And you can adjust the frequency interval at here if you want. And then output item can supply integration total. Okay. Make sure you click for current speed and current direction. Okay. And normally kalau you klik lagi banyak, lagi lama model you akan run because a lot of parameter the model need to create. And kalau in other ways, maybe some project you have to use it others parameters, so it's safe to click all. But in this case, we just click for. Okay, then I'll continue. After we create area file, we will create for airway point file. Sebab nanti kita akan validate dengan field measured airway data. So we have for airway, then we go for point, go to the output config specification, choose for point series, choose for point, okay, choose for point, not area, okay, point. Then send goes Control D, then save as average. Then you can specify your average location coordinate at here. If let's say you got two average, then it's okay to create another one, new one at this icon, insert. Then just name it as like average one, average two. And yang ni, so after you want to validate is that the point is correct or not, go to the geographic view. Then it will show you out the point here. Okay, contoh you can press zoom in, you will zoom in. Okay, betul tak point ni kat sini? Kalau betul, then you can proceed for output item. Okay, then select for, remember to tick for current speed and current direction. And all this is depend, if you want to click, then you can click. And sometimes the model is blur, right? You can click for CFL number to check it's blur because of what things. Or you can check if the CFL number is greater than 0.8. Sometimes it will cause the model to blur. So you can check if the model is blue or not, and then we'll go for okay, then we'll move on to map transport. Then yang ni next week Min akan ajar macam mana insert all these parameter. For this case we just go for output, and then create new output. Same goes, put maybe put empty, then go to then output specification and use area series, then control D, maybe you put empty, empty transport. I'm not sure which need to take. I just take. Okay, there we go for the send transport module. Send goes go to the output and then new output. Then self-ST, similar transport, and then choose for aerial. Control D. Areas. Okay. Okay. Then just click run. Okay. Oh, kalau semua data dah ready, dia akan tunjuk all the green ticks. Kalau contoh ada data yang tak cukup ke, salah tarik ke, salah apa ke, dia akan keluar dia akan keluar contoh this one. Kalau saya letak off, juga. Okay, okay. Dia akan keluar tanda merah kalau tak boleh, kalau data tak cukup ataupun ada masalah yang something tak match each other, then it will come up red tick. Then this case just run start. Okay, please save. Remember to save before you run. Save as safeguard model simulation. Try. Okay, then save. Okay. Kalau model bro kan, dia akan automatic keluar something error here. So dia akan stop running if your model is blow. So in this case, I think it can run, but this one is my laptop, so it will take some time. So after you run, you can go for after the run is complete, it will appear at here the simulation is complete. Then you can go for model simulation. Dia kan ada satu notepad file at here, so you can open. Oh, okay. Sorry. I buka yang dah siap run tu. But this one is for web. Okay, it's okay. Then kalau dah run complete, dia akan tulis normal run completion. Then from this notepad, you can see.
Tak nampak.
Tak nampak?
Still seeing your screen yang simulation tu.
Okay, sorry. That dah siap run, you can go for the folder model simulation. Dia akan automatic keluar satu notepad. So from this notepad, you can open and have a view on it. If let's say the model is complete run, dia akan keluar satu words normal run completion. But sometimes if even in normal run, there are still errors that occur here. This one is for web, so it's okay. Then kalau ada apa masalah, dia akan tunjuk kat sini. after the computational start here, dia akan tunjuk contoh kalau for current, sometimes the water elevation is too high ataupun masalah lain dia akan tunjuk kat sini. Tapi dia still akan keluar normal run completion. So you have to check, double check here, the notepad file to make sure everything is correct. And then dari sini boleh nampak everything yang you dah set up. Dia akan muncul kat sini. Then your mesh information, your boundary information, got how many point, and also the parameter that you choose. For example, dah siap run nanti, dia akan keluar satu table ni, this one, data file summary. Yang ni untuk web je, just example. Kalau untuk current, dia akan keluar maximum current speed how much, minimum current speed how much, direction, maximum, minimum, then everything you can refer from this. If you want to do a table in your study later, you can extract the value directly from here. Okay. Okay. That's all. Kalau model tableau, dia akan auto keluar number hour yang berapa dia perlu run. Contohnya this is 4 hour, it mean it needs 4 hour to complete this model. Sometimes lepas dia run 1 jam, maybe dia blow juga. It depend on the model. Yeah. Okay. Okay. That's all. Any questions for HT?
Tak ada.
On this parameter, everything clear? Contoh kalau graph, if let's say sometimes your validation is like kurang reinforcing, dia macam lagi rendah, model result is lower than the measured result, you can try to adjust it here, try to play around this. Wind forcing, you can click plus icon and then go for wind friction. And then, wait, anything? Shadow. Sorry, I tak record ya. You kena record sendiri sebab laptop I ada masalah. And then, wind friction ni, you will try play around. Normally, I will play with this, varying with wind speed. And then, yes, try to adjust this value. Sebab wind ni you extract from satellite, it might have some error or less forcing, so you can adjust in this parameter. If you're using constant, then you can adjust this. Sometimes the pattern will run, akan lari sikit pattern, then you have to adjust at this. So there are 3 parameters I can suggest for you to adjust is wind forcing inside the wind friction part, and then eddy viscosity, and also bed resistance. These 3 you can try to adjust. And the most important one for validation current only, pure current, is your tidal data. Make sure your tidal data is accurate. That's the most important one for the pattern looks. And then for the forcing one, if the pattern is look nice but still under estimate, then you can try to adjust these 3. Okay, that's all my suggestion. So anything else you want to ask? If no question, then I think we stop here today. And next few weeks, Min will continue for web module and also MT and ST module.
Okay, thank you, Yun.
Okay.